All right, Algebra 2, we are starting a whole new unit today, only our third unit, but in this unit we will be talking about exponential and logarithmic functions. So first of all, we'll spend topic A talking about just real numbers. Okay, it should be some review for you. And then in topic B, we'll start talking about logarithms, which are a ton of fun. Actually, I love real numbers too. So I hope you enjoy this as much as I have. First of all, crazy opening exercise. Can you fold a piece of notebook paper in half 10 times? Okay, I tried it. No, I couldn't. Okay, I tried. You may think yes, but in actuality, oops, I tried. It didn't work. My goodness, I can't even spell. How thick will the folded paper be? I tried. It didn't work. So I guess I shouldn't have said that I tried. I should have let you guys guess on your own. It didn't work. Will the area of the paper on the top of the folded stack be larger or smaller than a postage stamp? So let's just think about it. If I divide an 8.5 by 11 inch sheet of paper, if I divide the rectangle in half 10 times, so if I just divide it in half, let's see, 11 divided by 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11 divided by 2, 10 times, I get a 0.011. I'd say smaller, okay? Very small when divided in half that many times, right? All right. Right, what other information would we need to know to actually figure this out? So if I wanted to know how thick my folded paper would be, I would have to know the thickness of one sheet, right? Because one sheet laid on top of each other that many times, I'd have to know the thickness of one sheet. I'd have to also know the dimensions of the paper, which we just guessed. I guess if we had legal size, we may have a better chance of getting it done because it's bigger paper. And then I don't know how big a postage stamp is. I have no idea. I could look it up. Right? All right. Let's do some more work. Right, what are the dimensions of our paper? I'm using regular notebook paper, so 8.5 by 11 inches. Goodness. 8.5 inches by 11 inches. How thick is one sheet of paper? So I grabbed a ream of paper. A ream has 500 sheets in it, and I measured the thickness. Okay, 2 inches high. Do some division. We want to know how many inches for each sheet. So 2 times 500, which is crazy to think. Divide by 500 gives me 0.004 inches of thickness. Not very thick. Describe how you folded the paper. So I would take 8.5 by 11 and I would fold it in half, right? So now this is 8.5 by 11. Now I'm 5.5 still by 8.5, right? Then I'm going to rotate it, and I'm going to have 8.5 by 5.5, and I'm going to fold it again so that it is 4¼ by 5.5. Guess I should use decimals for everything. Right? Then I'm going to rotate it again and fold it again. You get the idea? So I'm going to put all of that into a table because I like things organized. Okay, I'm going to push pause and go ahead and fill this in. We know the thickness. That's easy. 0.004, 0.008, etc. So I'll be right back. So there you go. Those are all the thicknesses. You can push pause and fill in your table. Okay? Now, area of the top of the stack. So with the pictures we just drew, like in box 0, we would have 8.5 times 11 as our answer, right? So 8.5 times 11 gives me 93.5. It's going to be hard for me to write. 93.5. Now, with the second drawing I had, if you remember, it was 8.5 times 5.5. 46.75. Then I turned it again, and I folded it in half, and I got 4.25 times 5.5. That gave me 23.375 if I multiply that out. Okay, so I'm going to push pause and finish here, and you should do the same. Okay, the area of those last few are really, really, really tiny. I had to round at some point because I couldn't fit all the decimal places in there. So, part E. Were you able to fold a piece of notebook paper 10 times? No. Too small. Not enough paper to fold anymore. Right? Okay, it was too thick and too small. Alright, this last one is sort of hard. Create a formula that approximates the height of the stack after n folds. I mean, it looks like we just doubled it every time, right? So if we doubled it every time, our height with n folds would be 2 times, or 2 to the n. Because when it's 0, you get 1. Actually, it's the thickness times, sorry. Thickness times 2 to the n. It would work for any paper. So our thickness was 0.004 times 2 raised to the n power. And you can test that out for our values of n. I just typed in a few to make sure I didn't mess up, and it works fantastic. Okay? Now create a formula that would give you the approximate area of the top after n folds. This is a little bit harder. So we have the area folds is equal to our initial area. What's our initial area? 93.5. And we're reducing that each time, right? So our initial area, and we're cutting that in half. Okay, that one was sort of hard to come up with. Excuse me. So I'm just going to state that our initial area is 93.5 inches squared, which you saw in the original table. Right? So that one works great. Answer the original questions from the opening exercise. How do the actual answers compare to your original predictions? Well, I ruined the original predictions, so there's no difference, right? Okay, let's talk through something really quick. I want to talk about that area, the area formula that we sort of decided on, the area sequence. So we're really doing a successive division by 2. So we're dividing by 2 multiple times. So there's just an example, 100 divided by 2. 100 over 2 is the same as 100 times 1/2, which is the same as 100 times 1/2 to the first power, which is the same as 100 times 2 to the negative first. Let's do it again. Okay, it's the same as 100 times 1/4, or 100 times 1/4 to the first power, or 100 times 2 to the negative 2. See that last one? Ooh, sorry. Let's change this. It'll make better sense. Cool. Okay, one more. 100 times 1/8, 100 times 1/2 cubed, 100 times 2 to the negative third. Okay, sort of shows us. Here, I'd like to make sure that we see, because that's what we're doing today. This is called our base, and that is our exponent. Okay, these are really important ways to label what we're doing, okay? So, we're going to actually rewrite some things now in hopes that it makes sense. Alright. Alright, if you see here, this table displays the thickness and area of a folded square sheet of gold foil. In 2001, Brittany Gallivan, a California high school junior, successfully folded a 100 square inch sheet of gold foil in half 12 times to earn extra credit in her math class. No, you can't do that. Rewrite each of the table entries as a multiple of a power of 2, and you'll see some are done for you. So 0.28 is the same as 0.28 times 2 to the 0 power. 0.56 is the same as 0.28 times 2 to the first power. So this next one's going to be 0.28 times 2 to the second power. I'm going to grab my calculator and just check. So 0.28 times 2 to the second power gives me 1.12. So you see the pattern? Oops. Awesome. So I'm going to have 2 to the third power, 2 to the fourth power, 2 to the fifth power, 2 to the sixth power. Okay, you can check a few of those and see how it works. So the area is going to be cut in half each time, right? So just like I showed you in the last example, this is like 100 divided by 4, or 100 times 2 to the negative 2. 100 times 2 to the negative 3, because that's divided by third. 100 times 2 to the negative 4. 100 times 2 to the negative 5. And you can test these out. Grab your calculator and make sure they work. Okay, I'm going to try that last one. 100 times 2 raised to the negative 6 power. 1.5625. Awesome, it worked. Okay, let's do some Algebra 1 review. Actually, it's sort of pre-algebra review, but it's alright. So, just little reminders here. When I have 4 to the 24th power, it's really 4 times 4 times 4, 24 times, right? That should be times. Now, if I had 4 to the negative 24th power, it's 1 over 4 times 4 times 4, 24 times. Correct? So we could also say that 4 to the negative 24th power is 1/4 times 1/4 times 1/4, 24 times. Yuck. Okay, just a little reminder there. That's what we're doing. Some other things I want to remind you of. This is just pure, these are the rules. If we have x to the a times x to the b, notice these are the same bases. We get a to the x plus b. Okay, x to the a times x to the negative b, it's still a to the x to the a plus negative b, or a, oh my goodness, x to the a minus b. Okay, these are all rules. I'm going to keep going. X to the a raised to the b means we multiply x to the ab. Now what if it's x to the a to the negative b? Well, that gives us 1 over x to the a to the b, or 1 over x to the ab. Okay, let's go backwards. xy to the a, x to the a, y to the a. How about x to the a, y, quantity to the b? Well, that gives us x, a, b, y, b. There's more. How about x to the a over x to the b? We sort of did this one a little bit. We can keep going, right? All right. Let's try some real problems. All right, these turned out really small, but it's okay. It says rewrite each expression in the form of k times x to the n. So we need k would be a real number, and x to the n. X is your variable, n is an integer. N can be positive or negative. All right, so here we have two terms multiplying by each other. So I can take 5 and negative 3 and multiply them to get negative 15. And now I need to look at my exponents. So I have x to the 5th times x to the 2nd. So that gives me negative 15. Remember, you add your exponents. Negative 15, x to the 7th. Now, in my book, it wants me to write out all the x's. I'm not going to do that because I expect you to be able to add your powers, add your exponents to get the answer, okay? So first thing we did was we collected the numbers and we multiplied them. Then we collected the variables with the exponents and we did what we needed to do. Cool? Alright, how about this one? I have 3x to the 5th over 2x raised to the 4th. I'm going to distribute that 4th power. So 2 to the 4th power, x to the 4th power. That gives me 3x to the 5th over 2 to the 4th power is 2 times 2 is 4 times 2 is 8 times 2 is 16, x to the 4th. Okay, it wants it in this form, so I'm going to say, okay, 3 over 16, and then I have x to the 5 minus 4. 3/16 x. Okay, another one. Remember that negative power raises it to the numerator. So 3x squared to the 3rd power. That gives me 3x to the 2 times 3 power. 3x to the 6th. Okay, here, lots of negatives going on, so let's get everything positive. X to the 4th over x to the 3rd times x to the 8th. X to the 4th over 8 plus 3 is 11. Simplify more. X to the 4 minus 11 gives me, okay, as much as I hate to circle something with a negative and an answer, that's how they wanted us to put our answers together, right? Okay, now these are your exercises. Why don't you go ahead and practice these, and then we'll be done to start our problem set. So I'm going to push pause and go ahead and work them. Okay, there you go. Push pause and check your work. Again, push pause. All right, there's 3 and 4. One more. Go ahead and try it. Be right back. All right, there you go. Okay. There's a summary of all the rules I've already given you. Oh, I didn't go over this one. Very important one. But you can start your problem set, and it'll be a lot of fun.